Hello and welcome to another section in further mathematics. In this section we'll be looking at the topic trigonometry. But before we move further, I would like us to do a quick review of our previous lesson. Now welcome back. Now you can still remember when we talk about trigonometry, we have the basic functions that makes up trigonometry, and these functions sine theta, cos theta, and tan theta. But we need to perform a lot of job on this in trying to get how to get our values of sine theta, cos theta, and tan theta, and that can only be achieved by using the Pythagoras theorem. Now, what is the Pythagoras theorem? The Pythagoras theorem states that the square of the hypotenuse of a right angle triangle is equal the sum of the square is equal the sum the square of the other two sides of the triangle. Now we have to explain this using a right angle triangle. Now these are right angle triangle. These are right angle triangle, and it's been called a right angle triangle because at this point we have a 90 degrees. Let's call this part our H because we have A, capital H, and B. And here let's call here. So what this Pythagoras theorem is trying to tell us is that when you square the hypotenuse, that happens to be the longest side or the side facing the right angle, when you square it, is equal to the sum of the square of the other two sides. This is A. This is letter A. So H square is equals A square plus B square. This is what Pythagoras theorem is telling us. But this is the angle here, and we are used to the saying that goes so ka tua. I know you're hearing so ka tua. Now this part is called the hypotenuse. The hypotenuse. Now the side facing the angle is called the opposite, and the other side is called the adjacent. Now using SOHCAHTOA, X, the first letter in so stands for sine, the first letter here stands for cosine, and the first letter here stands for tangent. If you apply this is opposite, that is this point. Hypotenuse are H. Cos is adjacent, which is A, over hypotenuse, which is RH. Then tan is opposite over adjacent, which is A. So if I should tell you to give me the value of sine theta, you tell me that sine theta is equal to, you come to SOHCAHTOA, we make use of our SOHCAHTOA here. Sine is equal to opposite, which is B, over hypotenuse. The hypotenuse here is small h. Then the value of cos theta adjacent, which is A, all over hypotenuse, the h, and tan theta. Tan is opposite, which is B over adjacent, which is equal to R A. Now with this, we can use this in evaluating any form of trigonometric function that is being given to us. But one thing I want us to know is that the inverse of each trigonometric function can be stated thus. So we have sine theta, the inverse of sine theta, that is 1 over sine theta, is known as cosec theta. That of cos theta, the inverse of cos theta, is known as sec theta. And that of tan theta, the inverse of tan theta, is equal to cot theta. This is for sine, cosine, and cotangent. So you can call them using this format. So with this, and I'd like us to also note that sine theta over cos theta is equal to tan theta. Now let's prove it. We had sine theta to be B over H. Sine theta is equal to B over H. We had our cos theta to be equal A over H. A over H. Now I want us to define sine theta over cos theta. We'll have B over H now times H over A. So that H goes with H. We now have B over A. So sine theta over cos theta is B over A. Now let's see the value of tan theta. And our tan theta here is also equal to B over A. So you can see that sine theta over cos theta is the same thing as tan theta. Now we have an example in front of us to deal with, and we'll call this our example 1 in trig. Given that sine theta is equal to 5 over 13 and theta is acute, find A, the value of cos theta, B, the value of tan theta, C, the value of sec theta, D, the value of cosec theta, and E, the value of cot theta. Now with this, what we need to do is to produce the right angle triangle before we start solving. So with this is a right angle triangle with this point being 90. So theta, this is the value of our theta. Let me explain this, and theta being acute. Acute angles are angles that are less than 90 degrees. So the value of theta is less than 90. So with this, we now have our theta to be, they said, remember our SOHCAHTOA. So opposite is 5, because they said sine theta is 5 over 13 and hypotenuse was 13. Now what we need to do is to look for adjacent, so that it will enable us look for all these things that is required of us. Now let's go into looking for the adjacent. Remember that 13 square is equal to 5 square plus a square. Let's call this point our a square. So we have our 13 square is 169, is equal to 25 plus a square. So with this we have 169 minus 20 minus 25. So we now have equal to a square, and 169 minus 25 is 144 equals a square. So the value of our a is the square root of 144, which is equal to 12. You know, 144 is a perfect square, so the square root of 144 is equal to 12. Now if this point is 12, let's start applying SOHCAHTOA. Cos being the first thing that we are required to submit, cos theta is adjacent, which is adjacent now is 12, over hypotenuse over 13. We are done with cos theta. We are done with cos theta. Then that of tan theta is opposite, which is 5, all over adjacent, which is 12. We are done with this. Now, what did I tell you again? It was sec theta. Sec theta is equal to 1 over cos theta. So, and 1 over cos theta will now give us the inverse of cos theta. So, sec theta is equal to 13 over 12. Now, that of cosec is 1 over sin theta. And 1 over sin theta will give us the inverse of sin theta, which is equal to 13 over 5. And cot theta will give us inverse of tan, which is equal to 12 over 5. So with this, we've done justice to all this. We've gotten the value of cos theta, tan theta, sec theta, cosec theta, and cot theta from the given equation. So one of the things I'd like to tell you is to always make use of our platform. But before you leave, make sure you take the test that will be appearing shortly on your screen. Just do well to always make use of this platform for better information on the topic we've discussed. Thank you.